This work that I'll describe now was motivated by what was going on in the Lake Champlain Basin over about the last half decade or so. Probably many of you know that the TMDL, or the Water Quality Improvement Plan for the lake, was turned back by the EPA as a result of a lawsuit several years ago. And as the task came back to the state to draft a new TMDL, the question more or less was asked is, are our sort of underlying assumptions about sources of pollutants to the lake correct? Like, do we need to look beyond the typical sources? And by what I mean by typical is, there's pretty clear understanding that agricultural practices in the lowlands are a major contributor to water quality degradation. And the state has done a lot of work in understanding the role of unstable riverbanks and channel migration in contributing. But the uplands were more or less written off. Sort of, the forested uplands are net protectors of water quality, and we don't really need to do anything in the uplands to improve water quality because forests protect water quality, and the uplands are largely forested. But if you go up into the uplands in the Lake Champlain Basin and look around the road network, that the evidence suggests otherwise, that while forests clearly are important in protecting water quality, this extensive network of gravel roads that we have in our watersheds are clear producers of sediment. And the phosphorus story is a little bit more subtle in many cases. And so I had been engaged in this road work. When I left the Pacific Northwest, my advisor had actually nicknamed me the ditch bitch, and I said, I'm never going to work on roads again. Then I got into this situation where the Lake Champlain Basin program really wanted to know how important roads were, and I decided, I guess I'll jump back in again.
You're the one.
And so over the last 4 years, we've really done 3 different studies, and I'm using these pictures to cartoon. The first one was actually initiated by Leslie Morrissey, who was interested in doing some GIS analysis with the geomorphic data that the state had collected to ask, are there ways in which we could explain geomorphic condition of upland streams that might be related to characteristics of the road network? And that work is published. I'm not going to talk about it today. We basically developed a whole set of road network metrics and found, when comparing them to streams that had no other development other than roads above them, that you could actually detect degraded geomorphic condition associated with certain aspects of the road system. So we started that work first, but then as part of this Lake Champlain supported study, we ended up doing a series of studies that started with doing some on-site runoff and water quality measurements, and then some inventories, and ultimately some manipulative work with some towns to look at the effectiveness of best management practices. And I'll sort of run through a few slides to describe what that looked like. This is what some of the data looks like that we collected. We basically instrumented road segments with little V-notch weirs and water level recorders and automated water samplers so that we can collect hydrographs, the blue lines off of road segments, and water quality measurements, that's total suspended sediment, but we also measured phosphorus in those samples. And we chose a set of roads in the Mad River Valley because what we wanted to know was how much pollutant and runoff production was coming from roads, but we wanted to compare that to what was coming out of catchments. And the Friends of the Mad River had this data set where they'd been sampling along the river and in tributaries, and we used their data to construct load estimates coming out of these catchments that I have highlighted here, and then from our measurements, what was coming off of roads. And so there are a lot of intermediate steps between that and this, but this is sort of a summary of those results. So for suspended sediment and total phosphorus, the black lines and the blue lines are estimates of loads coming out of those catchments, and then the red lines are estimates of loads coming off of the road networks in those catchments. And what we found, there are big error bars around these estimates too. But what we found is that in these places, roads probably explained somewhere around 10 to up to 30% of the suspended sediment loads, and more than 10 to as much as 35% of the phosphorus loads. So instead of writing off, so to speak, the upland landscape as being unimportant for pollutant production, the results sort of point in the direction that we probably do need to address water quality degradation associated with gravel roads. Another piece of that work was this inventory study that we did. That work had just been in the Mad River Valley, but we went throughout the Winooski River watershed, pictured here. So that earlier work was just here. But we did this inventory study throughout the Winooski River watershed and essentially just mapped erosional features along the road system and used that to look at sort of the magnitude of volume of sediment produced per unit length of road. So that bar graph is just for each of these sub-watersheds, the amount of sediment or the volume of sediment produced per unit length of road. And the variability among those sub-watersheds can be explained to some extent by the slope of the catchment. So this is the steepest part of the Winooski Valley, and those watersheds in the steepest part had per unit length of road the biggest erosional features on the road network. And so in some ways, I've taken a slide out of here just to keep moving, but in some ways that sort of observation helps sort of narrow the thinking around where would you target remediation measures. If you know that it's a slope steepness problem, then you could target remediation by going into the steepest parts of the landscape and addressing those road segments. And then this third part of the work, and this was a separate grant, this was supported by the USGS and the Vermont Water Center. The state started asking questions around, well, can we address some of this erosion by best management practices? Can we go in and put in treatments that would reduce the amount of erosion, pollutant transfer off of roads? And so we struck up a collaboration with the Better Backroads program, which is a Vermont-based, now Agency of Transportation program, that funds towns to do improvements on their gravel roads to improve water quality. And in this study, I just need to figure out where I am. In this study, what we did is selected, in collaboration with the road foreman in a set of towns, selected a set of road segments that they said are an erosion problem that they wanted to treat. And then we coupled those road segments with what we called a control, a segment of road that looked very similar, but that we weren't going to treat with any BMP. And then we constructed silt fences below culverts, and every time there was a storm, we would go out and shovel sediment and dry and weigh that sediment and get an estimate of how much sediment was coming off of the road segment and analyze those samples for phosphorus too. And then after a period of time of that pre-treatment monitoring, then the town went in and constructed some BMP. In this case, they put in stone into the ditch, and we continued to monitor sediment runoff off of both the control site and the treated site to look at the impact. And so here's what those data look like for these three sites that were all treated with stone-lined ditch. The blue points are storm events after which we measured the amount of sediment. And you're just looking at a point that represents the amount measured on the controlled site versus the treated site. And so if you can see the magnitude of the numbers, in every case, the treated site produces more sediment than the control site, because the treated sites where the road foreman said we've got a lot of erosion, we need to reduce it. But also in every case, once they put in the treatment, there's this dramatic drop in the sediment production. So essentially in this case, by lining the ditches with stone, they reduce the sediment production down to virtually zero. And that's good news, because it means we can effectively and not very expensively address the problem.